I want to enter data into my calculator, I'm going to press the Stat button. Now you see it says Edit, and it also has Clear List. If I go to number 4, I can clear the list. But before I do that, let's go check if there's anything in the list. So let's clear this and go Stat, and I go Edit. Now I've got some things in there, and if I don't want them, I can go to Stat, Clear List, and do List 1, second, number 1, comma, second, number 2, and it'll clear the list. But I want to use this. This comes from problem number 2 in 1.1. So I'm going to clear that. I go back to my list, and I've entered all the X data in here, and I've entered all the Y data in here. So what I want to do is I want to do a scatter plot. So I'm going to hit second, Stat Plot. I want to turn it on, and I want to make sure I go to the scatter plot. That's this first one here. And then once I hit enter, notice it changes things. So I want to hit list 1, and I want to go list 2. I'm okay there. If I do not push zoom stat, I won't see it because it depends on my data what window I need. So I go zoom, and I'm going to scroll to stat, which happens to be number 9, and hit enter, and there is my scatter plot. It doesn't look very linear. So if I look at my tables, I got to decide what table to use. Well, it kind of looks like this one. So I look at my data, look at my window. This is -1 to 7, -4 to 40, and that would cover X-min, that would cover, and that would cover. But let's also look over here. Down here, that's too big a window. I don't think I need that one. It could also do this one, so it could be one of those. Let's see which one we are looking at. I'm going to try the smaller window. So I'm thinking that it's going to be the smaller one. And now I got to find out what kind of equation this is. It doesn't look very linear. So what I'm going to do is I'm going to say Stat. I'm going to go to Calc. And do you see the quadratic regression? Quad reg. So I'm going to hit number 5. Now yours may not look like this. Yours might already have what list you're going to put in. Now I'm going to put list 1, comma, list 2, comma. Now if I want it to graph it for me and I don't want to enter it into Y1, I'm going to hit vars, yvars, function, Y1, and hit enter. Now it did a quadratic regression for me. So it's going to be x squared. Now this is practically 0. It's a pixel issue. I'm going to call it 0. So what I've got is x squared plus 2. And it looks like it's a right-on fit. As you can see, the r squared equals 1. So this is the equation, x squared plus 2. And so now for number 2, I have picked that it's going to be graph f. And the equation is x squared plus 2, which is letter R. So that's what this equation is. So I'm going to hit clear. And we're going to look at exercises 11 through 18. There is a table of values there that show the percentage of female and male population in the United States employed in the civilian workforce in certain years. Measure the time in years from 1955. So what I'm going to do is go to my list. And if I look at my list, I have some things in there. So what I'm going to do is stat, number 4, list 1, enter. If I go back to my list, it should be gone. So now what I'm going to do is I'm going to call 55 0, and then 5, 10, 15, 20, 25, 30, 35, 40, 45. Now in list 1, list 2, I'm going to put the percentage of the women. So I start off at 0 and I'm going to put 35.7. These are the percentage of women that are in the civilian workforce. And let's see, we keep entering, we keep entering. I filled in list 2, now I'm going over to list 3. This is the percentage of men in the civilian workforce, so I'm going to push 85.4 and then 83.3 and keep going till they're all. It's always a good idea to check to see if you have equal number of entries. Otherwise, you'll get a mismatched data. And it's always a good idea to go back and check to see if you put in things correctly, just in case you typed it in wrong. So now I have all that stuff in there. And what we need to know is, if we looked at the numerical model, 11A says, what has been the trend in the females joining the workforce? Well, looking here, it looks like more have gone into the workforce, just looking at the numbers. In part B, in what 5-year interval did the percentage of women who were employed change the most? So what you'd have to do is, this is 2%, this is a little bit less than 2%, and you go through and check each one of these, which one has the greatest percentage. Now in number 12, if you had to do the same thing with the men, you would see that the percent in the workforce has been going down. And again, the greatest change between these two would be the one that would answer part B. In what 5-year interval did the percentage of men who were employed change the most? And so you just subtract these two and see which one has the bigger difference. So what I did was look at the differences between these two. And we have to find in both 11B and 12B which one had the most change. So if I look, the 5-year period that had the most change for women is this one. And the period that had the most change for men is this one. So what I've got to say for 11B, in what 5-year period, it was between 75 and 80 that more women joined the workforce. And it was between 60 and 65 that less men joined the workforce. Number 13 asks us to do a scatter plot of both. So what I'm going to do is do y equals, and I go up to the stat plot. I hit enter. I want it on, and I want it to be a scatter plot. Enter. And I want it to be list 1 versus list 2. I also want to go to plot 2. I want to turn that on, and it's a scatter plot, and I want that to be list 1 and list 3. List 3 for the men. And since I want both of them to be on, I'm going to come over to here and turn this one on as well. So they're both on. Let's go over here and you'll see they're both on. And so what I'm going to do is hit zoom 9, and we will see the trends of both. This is the women, this is the men. So that would be what number 13 asked us to do. And if you graph this on a piece of paper, you must, when you graph this, you must put labels. So you have to have years here, and you have to have percentage in the workforce, and you would have to put employment statistic titles, employment statistic as a title, and then you would have to possibly have pluses be women and maybe dots be men, and then you would actually copy this, okay? And you can find out where they are by hitting trace, and it will give you, as you hit the right arrow, all these. And so that's how you would graph that. And you'd come along here, and you would have these dots for the men, and you would have pluses for the women, and it would kind of go like this. Okay? And I need to put a scale down, which I will let you guys do. And the scale is basically what you see in your table. So you would have this as 1960, and this one here would be 1965, etc. All right, now let's look at number 14. Are the male percentages falling faster than the female percentages, or vice versa? Well, I'll look at my table. It looks like, if you look here, this one's going pretty steady while this one's increasing quite a bit. So what I would say is that it's the female percentages that are changing quicker than the males. Now we'll look at number 14, or number 15. Now they want us to model the data algebraically, and they ask us to use 2 different points. And the points they ask us to use for number 15 is they ask us to use 1955, which relates to 0 and 35.7 for the women, and 0 and 85.4 for the men. And then they also ask us to use 1995, which ends up being 40 years. And then the points would be 58.9 in 40 years and 75.0. And they're asking us to find this particular equation of a line the old-fashioned way.